Hello my dear students, in this video let us solve some of the problems related to polynomials in Maths 9 written by R.S. Aggarwal. I hope you are aware of terms, coefficients, factors of algebraic expressions. If not, please refer to the video Algebraic Expressions Part 2 in this channel. Let me give a brief explanation of the polynomials before we start solving the problem. Algebraic expressions in which some constant, say 2, multiplied by a variable raised to some power, let us say 4, plus some other constant and the same variable raised to the power 1 less than that, that is 3, and some other constant multiplied by the variable raised to the power 1 less than the previous one, plus again another constant with a variable raised to 1 and some other constant with variable raised to the power 0. This type of expressions are polynomials in variable x. Now let's generalize this. The constant may be written as a n x power n some n plus a n minus 1, where x is raised to the power 1 less than this, plus a n minus 2 multiplied by x raised to the power 1 less than this, goes on like this till a1 with x raised to the power 1 plus a0 with x raised to the power 0. This is the generalization of polynomials. Here n is the degree of the polynomial. The highest power or degree of the variable is the degree of the polynomial, and in this expression we have x to the power 4, so this polynomial is of the degree 4. The polynomials of degree 4 are called biquadratic polynomials. If I remove this, we have a polynomial of degree 3. This is cubic polynomial. If I remove that, I have x raised to the power 2. So this is a polynomial of degree 2 called quadratic polynomial, and now this has x raised to the power 1, which is called linear polynomial, and here x to the power 0 we know is equal to 1, so we only have a constant term in this, so this is the constant polynomial. I am referring to this book, and in page number 47 we have exercise 2a related to polynomials. We are going to solve some of the problems of this. The first problem says which of the following expressions are polynomials, and here let us see which are not polynomials and why they are not polynomials. In case of polynomials, the power we have required to be non-negative integer. So based on that, let us see which are not polynomials. The rest are the polynomials. Here, first problem is a polynomial of degree 5. Second polynomial is of degree 3. Third polynomial is a polynomial of degree 2. And fourth polynomial is a polynomial of degree 100. Fifth polynomial is a polynomial of degree 2, and let us see the sixth one, which is x to the power minus 2, 2x to the power minus 1 plus 3. This is not a polynomial because it has negative integers. And the seventh one, that has a polynomial of degree 0 because it is a constant term, it is 1, and similarly The eighth one, which is having minus 3 by 5, which is also a constant, that is also a polynomial of degree 0. And the ninth one, which is x square by 2 minus 2 by x square, this is a non-negative integer, but this becomes x power minus 2 when we take it up, means 2 into x power minus 2, that is why this is a negative integer. So this is not a polynomial. Then the 10th one is a polynomial of degree 2. The 11th one is again 1 by 2 into x to the power minus 2. This is also a negative integer, that is why this is not a polynomial. And 12th one, where we have 1 by square root of 5 into x to the power 1 by 2 plus 1, where 1 by 2 is not an integer, that is why this is also not a polynomial. 13th one is a polynomial of degree 2. 14th one, which is x to the power 4 minus x to the power 3 by 2 plus x minus 3, where 3 by 2 is a non-negative rational number which is not an integer, that is why this is also not a polynomial. And the 15th one, that is 2x cube plus 3x square plus square root of x minus 1, where square root of x is actually x to the power 1 by 2, which is also not an integer, that is why this is also not a polynomial. The second main asks to identify the constant linear, quadratic, cubic and quartic or biquadratic polynomials from the following. Third one asks to write the coefficient of different terms. Here the first one, x cube in x plus 3x square minus 5x cube plus x to the power 4, the coefficient of this is minus 5. The second one is straightforward. The third one doesn't have x square, that is why the coefficient is 0. Rest of them you should be able to do. The fifth one asks to give the examples of different types of polynomials, and the sixth one asks to write the polynomials in standard form. Means you have to write the polynomials in the descending order of the power of the variables. Let me take some problems of 4 to determine the degree of each of the following polynomials. To find the degree of the polynomial in this case, we need to simplify this. This becomes 4x by 2x minus 5x square by 2x plus 6x cube by 2x. When you simplify, 2 1s are 2 2s are 2 1s are 2 3s are. So we have x get cancelled, and here x into x divided by x, so 1x remains. Here x into x into x divided by x, 2 x's remain. So this is 2 minus 5 by 2 x plus 3 x square. So the degree of this polynomial is 2, that is the highest power of the variable. Third problem, this is equal to 2x cube into 3x minus 2 plus 3x square into 3x minus 2, that is multiplying these two and multiplying these two. So this is 6x to the power 4 minus 4x cube plus 9x cube minus 6x square. If we further simplify, we get 6x to the power 4 plus 5x cube minus 6x square. So the highest power here is, therefore the degree of this polynomial is 4. The sixth problem in fourth main, that is x to the power minus 2 into x to the power 4 plus x to the power 2. This is equal to x to the power minus 2 plus 4 plus x to the power minus 2 plus 2. This is equal to x to the power 2 plus x to the power 0, that is equal to x to the power 2 plus 1. The highest power is 2, therefore degree of this polynomial is 2. Let us solve some of the problems of exercise 2b in page 51 of Mathematics 9 written by R.S. Aggarwal. I have taken the second problem. P of y is equal to 4 plus 3y minus y square plus 5y cube. Here we have to find out P of 0, P of 2 and P of minus 1. When we see a function of y here, what we have to do is, wherever we find the variable y, we have to replace it with 0 to find P of 0, 2 to find P of 2 and minus 1 to find P of minus 1. First let us find P of 0. So here P of 0 equal to 4 plus 3 into, wherever I find y I put 0, minus 0 square plus 5 into 0 cube. This becomes 4 plus 0 minus 0 plus 0 is equal to 4. So P of 0 is equal to 4. Now let us find P of 2. Again, wherever we see y, we replace it with 2 minus 2 square plus 5 into 2 cube. This is equal to 4 plus 6 minus 4 plus 8 into 5, 40. This is equal to 50 minus 4, that is equal to 46. So P of 2 is 46. Similarly, P of minus 1 equal to 4 plus 3 into minus 1 minus minus 1 square plus 5 into minus 1 cube. This is equal to 4 minus 3, 1 into 1, this is plus, again minus 1 it becomes, and here minus into minus into minus, that is minus into 5 minus 5. This is equal to 4 minus 4 minus 5 minus 9 equal to minus 5 is the P of minus 1. The fifth problem is this. We need to find P of 0, P of 3, P of minus 3 and P of minus 1, and there is, what do you conclude about the zeros of P of x? Is 0 a 0 of P of x? Follow the steps properly. I will directly write the answer and give the answers of the last two questions. Here we can see that for the value 3 minus 3 and minus 1 for x, the whole polynomial becomes 0. So the value of x to which the polynomial becomes 0 is called the 0 of the polynomial or root of the polynomial. So what we can conclude from this is these three things, that is 3, minus 3 and minus 1 are the roots or zeros of this polynomial. The next question asks if 0 is the 0 of the polynomial. Here we see that when we substitute 0 for x, we don't get 0 here. So 0 is not the 0 or root of the polynomial. We also note that when the power is 3 here, we get 3 zeros for the polynomial. That means the degree of the polynomial tells how many roots the polynomial has. I have taken the sixth main third problem. The problem says verify if 2 by 5 is the 0 of the polynomial f of x is equal to 2 minus 5x. Follow the steps here. So given f of x is equal to 2 minus 5x. To verify if f of 2 by 5 is 0. So this is what we have to find out. So let's see. F of 2 by 5 is equal to 2 minus 5 into wherever I find x, I substitute it with 2 by 5 and I get that 2 minus 5 gets cancelled, 2 is equal to 0. Therefore, f of 2 by 5 is equal to 0. 2 by 5 is the 0 of the polynomial. I am taking the seventh main third problem. Verify r of x is equal to x square minus 3 of x has 0 and 3 as the zeros of the polynomial. We can see that this is a quadratic polynomial where we have the degree of the polynomial as 2. That means we have 2 roots. We need to verify if 0 and 3 are those roots. Let's substitute. This is given and we take r of 0 is equal to 0 square minus 3 into 0, that is 0. R of 3 is equal to 3 square minus 3 into 3, that is equal to 9 minus 9, which is equal to 0. That is why 0 r of 0 equal to 0 and r of 3 equal to 0, which means 0 and 3 are the zeros of the polynomial. Let's take the eighth main fifth problem. Find the zeros of the polynomial, and the polynomial is given. How to solve this? So what we have to find out is the value of x to which this g of x becomes 0. To find x for g of x is equal to 0. Let's see. G of x is equal to 0 implies 5 minus 4x is equal to 0. This means 5 is equal to 0 plus 4x. I am taking it to this side. That becomes 4x is equal to 5, which means x is equal to 5 by 4. So for the value 5 by 4, this g of x becomes 0. That is why 5 by 4 is the root or 0 of the polynomial g of x. The last problem, that is the ninth problem, says if 2 and 0 are the zeros of the polynomial, f of x is equal to 2x cube minus 5x square plus ax plus b. Find the value of a and b. This is the expression. So given f of 2 is equal to 0 and f of 0 is also equal to 0. Let us evaluate. Let me take up this one. F of 2 is equal to 2 into 2 cube minus 5 into 2 square plus a into 2 plus b. So this becomes 2 cube is 8, 8 into 2 is 16 minus 2 into 2 is 4 into 5 is 20 plus 2a plus b. This becomes 2a plus b minus 4. Since f of 2 is 0, we see that 2a plus b minus 4 equal to 0. We can say 2a plus b equal to 0 plus 4, that is 4. Let it be here for now. F of 0 is equal to 2 into 0 cube minus 5 into 0 square plus a into 0 plus b. Then this becomes 0 minus 0 plus 0 plus b. So f of 0 is 0, we know, which implies that b is equal to 0. Substituting this b equal to 0 in the equation we found out earlier, we get 2 into 2a plus 0 equal to 4, a equal to 4 divided by 2 equal to 2. That is why the value of a is 2 and b is 0. So in this video we have solved selected problems from the exercise 2a and 2b, and rest of them can be solved by you using the same knowledge. If you found this video helpful, please subscribe to the channel. Love Maths.